Hello friends, welcome to your civil engineering YouTube channel, and today we will discuss about the next part of numerical, that is elongation of varying cross section bars with the intermediate axial force. Already I have uploaded few videos on the basic part of simple stress and strain, and some videos on these two types of numericals, that is numerical on elongation and stresses calculations, and then elongation of uniform cross section bars with intermediate axial force. And today we will discuss about the third part, that is elongation of varying cross section bars with the intermediate axial force. Okay, so without wasting time, let's get start our today's lecture. See, third type is, as we discussed, it is based on the elongation of varying cross-section bars with the intermediate axial force. Here also we need to calculate the elongation. Okay. Here also our main aim is to calculate the elongation of the bar. But now, okay, this is third type of numerical, that is elongation of varying cross-section bars with the intermediate axial force. Okay, so main difference between this numerical and the numerical that we have discussed previously is the cross section area of the bar. Here we can see the cross section of that bar is of varying, means area is not same, but in previous numerical if you see that videos, so you can see the area of the bar is same throughout the sections. Okay, means all section having the same area. Here area is different, so formula is same. Whatever formula we have discussed in previous some videos, formula is same, that is elongation of first section, elongation of second section, and elongation of third section. So to calculate the elongation of whole section, first calculate the elongation of each section separately, and then calculate the final elongation of the bar. Okay, so let's start with the numerical. See, the first numerical is a member A B C D is subjected to a point load P1, P2, P3 and P4. These loads are given P2, P1, P2, P3 and P4. These loads are given as shown in diagram. Okay. Calculate the force P2 necessary for the equilibrium. Okay, calculate the force P2 which is necessary to maintain the equilibrium of that body. Equilibrium means the final resultant should be 0. Okay, if P1, this force is given, P1 is 45 kilonewton, P3 is also given, P3 is 450 kilonewton and P4 is 130 kilonewton. Then determine the total elongation of a member. Assume the modulus of elasticity to be 2.1 into 10 to the power 5 Newton per mm square. Now see, here we have to calculate two things, that is first is P2 force. Okay, P2 force, due to that the body will be in equilibrium. Okay, and the second thing, the total elongation of this bar. So if you see in this diagram, the cross section of that section is a different. Okay, or that bar is different, that is AB having 625 mm square. Area is also given in the bar or in that diagram. So for BC they have given 2500 mm square area, and this CD portion having 1250 mm square area. So area is given, the length of each section is given, that is 1200, 600 and 900 mm. Okay, and the forces are also given. So first we need to calculate this P2 force, because P1, P3 and P4 forces are given in the numerical. So for the equilibrium condition, just apply summation fx is equals to 0. Why fx? Because all forces are horizontal. So just apply summation fx is equals to 0, then we can calculate P2 by using that fx equation. So see, just as per our method, write down given data. P1 is 45, P3 is given 450 kilonewton, P4 130 kilonewton, and E is given, that is 2.1 into 10 to the power 5 Newton per mm square. But our forces is in kilonewton. Our forces is in kilonewton, so we need to convert that Newton per mm square to the kilonewton per mm square. So we know 1 kilonewton is equals to 10 raised to power 3 newton, 10 raised to power 3 newton. So just convert here, though it will be 10 raised to power minus 3 kilonewton. So just apply minus 3, so we will get the final uh, E is in kilonewton per mm square, that is 2.1 into 10 raised to power 2 kilonewton per mm square. So to find P2, just apply summation fx equals to 0 as we discussed. Fx, in fx we consider left side force negative and the right side force positive. Okay, right side force positive. So here 45 kilonewton towards left negative. Okay, then p force towards right positive. This p3 is towards left negative and p4 is towards right positive. So 45 plus p2 minus 450 minus 130, so that will be, just wait, that will be 365. Just wait, 45 minus 450 plus 130, 275. 45 is in minus, 45 minus 450 plus 130, 365. Okay, so just consider this p2 is in minus. Okay, it should be in minus. So by using this minus 45, so it is 365 kilonewton. Okay, 365 kilonewton. Okay, so now next, just consider the section one by one section and calculate the individual forces in each section. Okay, so for that, general, just consider section at B. Now see, A and D both points are free, so you can start your calculation from left to right or right to left. But as we discussed in previous video, we are using same method to all types of numerical. That's why we are starting our calculation from A to D, means left to right. So for that, just consider section at B point and focus on left part. So only one force is there, that is 45 kilonewton. The direction of that 45 kilonewton is towards left. So just consider opposite at B point, it should be towards right and magnitude is same 45 kilonewton. Now after that, just calculate force on second section. Okay, so just consider section at C point or near to C point and focus on left side. So if we see 45 is towards left and 365 is towards right, so 365 minus 45, minus 45, because this is towards left, so minus, and this is towards right, so it's positive or plus, so it is 320. Okay, plus 320. Due to that plus, direction of this 320 is towards right, so consider towards right 320 kilo newton. Okay, and then same opposite at C point, it's towards left, right, so it's consider this force is considered towards left. And same for last section, CD section. So at CD section, consider any section at DD point and then focus on left part. So 45 is minus 45, then plus 365, correct, and then minus 150, minus 150. So minus 150, so it is 130 kilonewton and opposite to this side. So by considering that section and considering left forces and summation, now here we get the forces on individual section. So 45, 320 and 130 kilonewton. So just consider the nature of that section. Okay, P1 is tensile, so consider positive, P2 compressive negative, and the P3 is again tensile, it's a positive 130 kilonewton. Area is already given in the numerical 365, then 2500 and 1250 mm square. So just put all the values. Okay, we will get the total elongation of the section. So delta L1 plus delta L2 plus delta L3, first section, second section and third section elongation. Just put all the values where P1 is 45 kilonewton, L1 is 1200, A area just calculate 365 and E1 is 210. Okay, similarly put the values for P2 L2 A E2, P3 L3 A and E3, and calculate, solve this equation, we will get the final answer, that is change in length equals to 0.4912 mm. So this is the total elongation of that varying cross section bar. Okay, so this numerical is for your homework. So just try to solve this equation or this numerical. A circular steel rod ABCD of a different cross section is loaded as shown in diagram. Find the maximum stress induced in the rod and its deformations. What we need to calculate? Maximum stress induced in rod and its deformations, where E is equals to 200 gigapascal. So here the vertical bar is given and the cross section is uniform or varying. Correct. The cross section is varying. So here two things we need to calculate: stresses induced in the bar and the deformation. So first thing is D point is fixed and A point is free. So obviously as per our rule we will start our calculation from the free to fixed. If both ends are free, so we can start our calculation from any point, A or D. But now here D point is fixed and A point is free. So definitely we need to start our calculation from the free end. So just write down all the given data that we have. D1 means diameter of first section is given, that is 25 mm. D2 diameter of second section. Now here we are considering section as per our convenience. This is first section, second section and third section that we are assuming. Okay, so D1 is the diameter of first section 25. In the diagram diameters are given. D2 50, 5 means diameter, and D3 70, that is 75 means 70 mm. Then lengths also given. L1 1 meter, L2 2 meter and L3 is 1 meter. So just convert it is in mm, because our diameters are given in mm. So E is given, that is 200 gigapascal, and we know gigapascal, 1 gigapascal equals to 1 kilonewton per mm square. So E is equals to 200 kilonewton per mm square. So first here we required the stresses, and also in the elongation formula we required area. So on the basis of that diameter, just calculate the area of each section, because we required it is in formula. So circular section is given. So formula for circular section is pi by 4 into d square. So pi by 4 into 25 square, that is the area of first section. Similarly pi by 4 into 50 square, area of second section, and the pi by 4 into 70 square, that is area of third section. So 490, 1963 and 3848.45 mm square, these are the areas of each section. So find the forces in individual section, correct? So first consider the section near point B and then focus on bottom side of that section. So only one force is there, that is 25 kilonewton. So consider 25 kilonewton, it is away from the body, and similarly consider at B point, it is also away from the body. Then second, consider second section near to C point and then focus on bottom. Two forces are there, 25 kilonewton downward and the 50 kilonewton upward. Okay, 50 kilonewton upward. So downward is positive, just consider downward is positive and 50 is negative, so it's minus 25 kilonewton. Minus 25 kilonewton means upward. So at C point, the 25 kilonewton is upward. Opposite at B point, 25 kilonewton is downward. Or we can consider 25 kilonewton is towards the body. So this 25 kilonewton is also towards the body. Anything we can consider as per your convenience. Now last, consider the section at D point and then focus on bottom. 25, 50 and 100. These three forces are there. 25 downward, let's consider it's minus. Okay. 50 is upward, let's consider positive. Okay. Again 100 is downward, consider negative. So it's 75, minus 75 kilonewton, and that minus 75 kilonewton means it is in downward. So at C point for CD section the force is in downward. Okay, force is in downward. So at A point it's 75 kilonewton is upward. So now here we get the individual forces on the particular section or the individual section. That is P1 tensile, positive 25 kilonewton. P2 compressive, so P2 equals to 25 kilonewton compressive, that is minus 25, and P3 is a tensile, so it is again plus 25, 75 kilonewton. So find the elongation. Okay, just put the formula as we discussed, delta L1 plus delta L2 plus delta L3, then we will get the total elongation. Put all the values that we have calculated in the previous slide, that is P1 25, L1 1000 mm, area 490.87 and the E is 200. P2 is negative 25 and P3 is positive 75. So just put all the values, we will get the elongation of that bar. So total elongation of that bar is 0.2248 mm. Okay, so it's 0.2 mm. Total maximum force is 75. So for maximum stress, okay, for maximum stress just consider sigma max equals to p max, divided by area. So here p max is 75, p max is 75 and the area is 3848.45. So just calculate this ratio and give your answer is in comment box. Okay, so this is for your homework, just noted it. Okay, thank you.